syllabus, it says you can make up whatever scenario you wanted for these. So we're actually a high school algebra 2 class, just got finished with logarithms, and we're sitting the week before Christmas break, so everybody's crazy, and I don't feel like starting something new. And I set this up as a lab, so it'll give you about a minute to read the first page and play with your slide ruler on your own. And there's 2 time scales in here. There's one for our class and there's one for real that I would actually use. So go ahead and spend a little bit of time looking at that. For the online students, I actually have posted where on our Moodle site where I've got the slide ruler from. So if you want to take some time and build it yourself, you're more than welcome to do it. Okay, now on our time compression thing, we're going to pretend that 10-15 minutes has gone through already. When you align the C scale up with the D scale, what did you find out aligned with 2, 3, 4, and 5? What aligned with 2 when you put when you lined up the C scale to the D scale? You can see on the back of that question page, there's actually pictures of what you could look at, the way it came out. Well, if you were to look, if you had the time, you would find out that on the D scale, on the D scale or on the C scale, excuse me, the 2 lined up with 4, the 3 lined up with 6, and so forth. So you were actually multiplying. And the rest of those, you guys can go ahead and try to do them at home on your own. I have to get going on this so I don't spend 25 minutes again. We're going to talk about how this thing works. Why does the slide ruler work in the first place? Who made the slide ruler? Impact of the slide ruler on math, engineering, and science. And whatever happened to slide ruler, you don't see pre-engineering majors or chemistry majors or math majors running around with one strapped to their belts. And in fact, when I was in here in '76, we didn't see them running around either. So what actually makes a slide ruler work? First of all, you got to go back to John Napier's discovery of logarithms. And with that, he converted multiplication into addition, and he also converted division into subtraction. So here on the bottom, I just put down 2 times 5 equals 10. Obviously you know that. Log of 2, and I used 4 places off my calculator like I had a chart. And log of 5 equals that. Again, pretending that I actually looked it up in a chart, and the chart's gone away, but this is what they did look like. And then you add those together and you get 1, and the anti-log of 1 is 10. So that covers why it worked. You just turn multiplication into addition. And then the other component of this is all real numbers can be expressed in scientific notation. 1, 2, 3, 4, 5 can be expressed as 1.234 times 10 to the third. And 0.4567 can be expressed as 4.567 times 10 to the first. So then you can do something else with the powers of 10. You can put them off the side and do something with them on your own. And so that's why the slide ruler kind of works. Here's an example of why it actually works. If you take y is equal to the number on the previous page times this, the answer comes out to be 563.6. If you go down, turn it into scientific notation, or factored it down so there was only 1 digit in the units place, move them around a little bit.
Hit the P button.
E button. What button?
P for previous.
P for previous. All right, there we go. And then applying log of y is equal to log of all the stuff multiplied together. Now from the exercise we had earlier, or the demonstration we had earlier, we know that when you multiply logs, you can sum the logs. When there's a product of a log, you can add the sum of the logs. In doing a little bit more advanced math, the sum of log of 3 times 2 is log of 2, and then that just becomes a 2. These are those numbers out of the charts. This is the number from the charts. So now notice I just added 2 logarithms together, carried them off with a couple more decimal places. So I carried the 2 off in the back of my head someplace is what I would really have to do. And then using the anti-log, I came up with the same answer. Now I had to do a little fudging with the rounding of it. That's one of the things you learn with a slide ruler, and the engineers learned it really well, that the significant digits really had to be kept accounted for. So the number of significant digits on your weighing equipment or your measuring equipment carried all the way through your calculations. If it was only 4, and that was kind of the limit of the more inexpensive one was 4 significant digits, they had to keep them all at 4.